Ivy is the magic behind the company's best days. Ivy for training and consultancy, outsourcing and empowerment. Ivy simulations, cost-benefit analysis for changing the layout.
Cheese production case introduction. Let's imagine that you are working for a cheese producer and your task is to find the optimal production batch. Use for this simulation method. Before we move on to Excel, where we will look at the data, let's have a look at the general information about the firm. So the firm is located in Poland and they're one of the biggest cheese producer in Poland. They produce a long ripening cheese and they cooperate with overall 1,000 local suppliers of milk. We will do the calculations only for one type of cheese, which has roughly 50 million of revenues, given the data that they have provided us. In the first step, in the next lecture, I will show you the calculations of the production cost that we will do for this specific production batch that they're currently using. And later on, you'll be asked using simulations in a similar manner that we did previously to try and estimate what would be the cost per kilogram of cheese for different sizes of production batch, and obviously find the optimal production batch. So let's move to Excel, where we will look at detailed data that we will use to estimate the cost of production per 1 kilogram of cheese. Let's have a look at cost per 1 kilogram for the current setup, where we produce only 4,000 kilograms in one production batch. So please open a file attached to the lecture, which is called Cheese Batch Simulation version 7 empty. And here in the master sheet, you will find, as always, table of content. We'll first go to the sheet cost, where we estimate the cost per 1 kilogram by looking at all the costs that a production batch generates, not only in production, but in the whole supply chain, and then calculating the cost per 1 kilogram. We're going to use it later on to carry out the simulation. So we start by estimating the variable cost, which is simply a multiplication of number of kilograms we produce and cost of material per 1 kilogram. Since it's 15 per 1 kilogram, we produce 4,000. Then in the case of the variable production costs, we would pay per one production batch 60,000 euro. Fixed cost consists of labor cost, waste, and some cleaning materials we have to use to clean the production line. In total, it's almost 90,000. Majority of that it's labor. Labor we estimate by looking first of all at number of people that have to be involved, the duration of one production batch, so it's 48 hours, and then we also have in the sheet parameters some hourly wage that we have estimated. So thanks to that, we are able to estimate the fixed production cost. As we said, we'll not be only interested in the production cost, but also in other costs that we generate in the supply chain. So the first position is warehousing cost. And here we simply look at how many pallets we need to have for how long. And obviously we have certain cost per one pallet per 1 day of warehousing. And the estimation of this cost is simply multiplication of those three elements. For time being, it's small because we don't keep too much stock. It's just 6 euro. We would also like to calculate the frozen capital costs. And for that, we first have to estimate the inventory level. Obviously, we would have to look at the average inventory level. So we look at the inventory level before receiving the production batch. For the time being, it's assumed that this is 200 kilograms. So there is some safety stock. And then once the production batch of 4,000 arrives, this will be equal to 4.2 thousand. Now, since the cost of material is 15, then the average level, which will be 2,000 and something, multiplied by 15 gives us 33,000 in terms of value. Obviously, this is the average level of the stock of finished goods, but only cost of material. So we don't calculate fixed cost. Now, we use that to calculate the annual cost related to this average inventory. And this is simply multiplication of the average inventory level in value and assumed interest rate in raw 36. So out of that, we get that annually we spend 5,000 on that. However, since we want to relate it to this production batch that we have now, we will only allocate a fraction of that to the total cost. And since we produce 4,000 in one production batch, whereas annually we produce 1.2 million kilograms, it means that out of the 5,000 that we've got here, only 16 can be allocated to one production batch. And the last thing we have to take into account is the fact that if we keep too much stock, we may throw it because of unplanned things happening to that. It may be damaged by people or by animals or by some natural cause. And we have the number of kilograms production batch, cost of material, so we look only at the cheese thrown away in the cost of material, and we have assumed a certain percentage of the cheese being thrown away, which is dependent on the size of production batch. So for this size of production batch, it's 1%. Therefore, the total cost of the cheese being thrown away, it's 600 euro. So the total cost would be visible here in row 50. It's almost 80,000. Majority of that is variable cost and also the fixed cost related to production. Here in column K, we also shown this in percentages. So 76% is variable cost, 23% is the fixed production cost per one batch. And the rest of the costs for time being are not that relevant. But from that we get in row 57 that the cost per 1 kilogram, it's almost 20 euro. Now the question is whether we can produce it cheaper and what would be the total savings if we achieve that. And this is what you will be asked to do in the next step. So please pause the lecture now. Open the file and try to run a simulation using the data what if analysis and data table option. As options that you should consider, look at the size of production batch that is suggested here in column J. They are equal to a specific number of days. So for example, the first option is equal to 1 day of sales. The second option, so the 7,000, it's 2 days of sales, and so on and so forth. So for every of this option, we want to calculate the cost per 1 kilogram and find the minimal value. So please pause now the lecture, open the file, do it on your own. And once you are done with that, move to the next lecture where I will show you the solution to this case study. I hope you managed to do the case study on your own, but just in case, let's go through the solution together. So please open a file attached to the lecture, which is called the cheese batch simulation. And here in the sheet cost below, we have already done the simulation. And as you can see, the cost is going down from almost 21 for producing on the level of 1 day of sales to 15.57 if we produce for 15 days of sales. So this is the row 78. And after that, it goes up. So as you can see, we have found the optimal solution, which is producing on the level of 15 days of sales, which will be 51,000 kilograms in one production batch. And this would be the production batch that would minimize the overall cost in the whole supply chain. We did it using the simulation. So if you didn't manage to do it, so let's do it maybe one more time. So let's erase everything we've got here. And here we should first take this table where on the very left we will have the size of the production batch. And here in H63 we've got what we want to optimize. So in our case, this is the cost per 1 kilogram. So you select the area, you go to data, which is above, then you pick what if analysis, data table. He will ask you what is the column input and the row input. In our case, we just have the parameters in the column. So we pick this one and we want him from the column to put it where we had the size of the production batch. So this will be the J7. We press enter and then we press OK. And now he should already have done the simulation one more time. So as you can see, we've got the simulation. So as you can see, once you've got the cost estimation, so you reflect the logic in Excel, it's very easy to do the simulation using this method. Now, the last thing is savings, and we have estimated them comparing current and target level. So we look at the cost, which is 26 million today, and they will go down to 90 million. We get the cost by looking at the cost per 1 kilogram, assuming obviously that we do specific production batch. So in the case of current solution, it's 4,000 kilograms, whereas in the target solution, we do 50-something thousand in one production batch. And thanks to that, we are able to generate 6 million of savings. And in the slide, we can see two things. So for the first thing we can see it's the cost per 1 kilogram, which is going down. And then below we have also shown the savings in a form of a waterfall. So the current costs are 25.6. We will go down to 19.5. So the savings are 6 million. So that's in short when it comes to this case study. I hope it was relatively easy to understand and useful. As always, if you have any questions regarding what we covered,